Hi everyone, thank you so much for coming. I'm just going to send the link to sign up in the chat. If you haven't signed up yet, it's essential to get your PEP hours to sign up. I am also going to send the link for the Slido, which is where our Q&A will be kind of held, where you can answer all your questions that we'll ask at the end. We've got 20 minutes of Q&A.
Hi everyone. My name is Olivia Bulmer, for those who don't know. I'm the events director for industry and academic for SUCE. Thank you all so much for coming. Our attendance records have been amazing. So we actually had around 600 signups for this event today. And unfortunately, with our Zoom limits, there is a limit of 300 participants. So we'll be working on that for our next event next week. But for those watching on YouTube at the moment, apologies. And yeah, it will definitely be fixed for next week. So welcome to the Civil Survival panel. Firstly, massive thank you to our lecturer, Benji Marks, for helping organize this. Greatly appreciated. And also thank you to Elizabeth, our events coordinator, who unfortunately could not host this event, but did all the questions and all the background work for it. And also thank you to the academics, which Olivia will introduce in just a minute. Greatly appreciate you taking the time to be with us for the next hour and a half. So our SUCE events coordinators, Olivia, will be hosting, and also Arch will be doing our Q&A. So I'll hand over to you, Liv.
Thanks, Liv. Yeah, so I'm hosting today's event. And I would just like to say a big thank you again to the academics for taking the time out of their day to be here today. I'm very excited to hear all you have to say. This first seminar hopes to serve as a guide for all the core civil units that you're going to do across your degree. And before we begin, just again, I'm going to remind everyone to fill out the sign up link if you haven't, to get your PEP hours, and also that the Slido link is also in the chat. So today we are lucky enough to have 3 experienced lecturers as our panelists to answer questions about 1,000, 2,000 and 3,000 level units. So our panelists today include, I think they're spotlighted on the screen. We've got Dr. Matt Bambach, who is the Civil Undergraduate Program Director, who will be mostly answering questions about 1,000 level units, but also can answer many things. And we've got Professor Zhang, who is the 3rd year coordinator, and Dr. Kapil Chauhan, who is the 2nd year coordinator. So thank you all for coming once again. I'd just like to start by asking you all what subjects that you teach at the university. Whoever, maybe, yeah, Howard, would you like to start?
Oh, okay, me. My name is Zhang. I'm an associate professor of this school. In this year, semester 2, I will teach several core subjects, CIVL4903, civil engineering design. I also teach part of civil depths elective, steel structure stability, that's CIVL5266. On graduate master level, I teach structural dynamics, that's CIVL6268. So thanks for having me.
Thank you. And Kapil or Mark, whoever wants.
Hi everyone, I am a senior lecturer here. I teach the 2nd fluids course, which is fluid mechanics 2. It is called CIVL3612. This is something that you will be doing in the 3rd year of your engineering. I also teach CIVL5670, which is reservoir, stream, and coastal engineering. And then I coordinate a course in wind engineering, which is CIVL5668.
Hi everyone, I'm Mike Bambach. I teach Civil 1900, Introduction to Civil Engineering, the 1st year unit. And I also teach a master's level unit, Civil 6267. And I'm also, as Olivia mentioned, I'm also the undergraduate program director for Civil.
Yes, so definitely a lot of coverage between the subjects between all of you, which is very helpful for us. So I'm going to start with directing questions on 2,000 level units towards Kapil, as he has to be away for a little bit in the middle. So my first question for you, Kapil, which can also be answered by Mike or Hal, if you would like, is what 2000 level unit do you think students struggle with the most? And do you have any advice for it?
Okay, thanks, Olivia. The question of a unit of study being hard or easy is relative because it also depends on your preference of what you want to pursue, but your own ability of understanding some concepts. As a general trend, if you think of units of study which has higher fail rates or lower marks, I would say soil mechanics, fluid mechanics, and structural mechanics are the 3 units which require substantial effort. Okay? There is a lot of things that you have to learn fresh, new concepts that are given to you. These core units, they require a good understanding of mathematics and physics, which is concepts. And one of the tricks to do well in this unit of study is time management. Try to keep up to date with the content that is delivered to you. So try to keep up to date with the tutorials, with the topics, and get in touch with your instructors or lecturers if you don't understand something before going to the next topic. One thing that you might not be doing is asking the instructor when you go to the first lecture, just ask them, what do I need to do well in this unit of study? Okay, and then they will say, well, maybe you should pay more attention to tutorials or in-class problems or read the textbook. So just ask them. If they're not addressing this aspect explicitly in the first lecture, you have to pose that question.
Yeah, I definitely think asking the professor at the beginning is great advice. It's something that I should probably do more, and I think lots of people. It's definitely a few complaints about the soil and fluids as well. They're said to be difficult. So my next question for you is, what are the most useful resources that you think more students should utilize?
I'm going to give a long answer here. Okay, and we are trying to arrange this so that you can get this information later on too. Obviously, it's recorded. First of all, you will learn a lot from your peers. So if you're not talking to fellow students, you're missing out. Form a study group. You can make a study group. You don't need to go for a beer with them. You just need to solve problems with them. Okay, so you can form a study group in your tutorials in the classroom, but that will be one of the biggest aspect of learning because there will be questions that you will hesitate in asking the tutor or the instructor. But if you have a friend, you can just ask and then you get an immediate response. The other thing is you have to, again, keep up to date with the content so that if you have any questions on a topic today, you can get that clarified today itself rather than having a heap of questions just before an exam or a quiz. Okay? So if you are keeping pace with the content that is delivered during the semester, you should be you should do well. So time that is a good resource for you to help. The biggest resource is obviously instructors and tutors. Not many students take this opportunity to answer questions. To ask questions. Okay, if you go to any lecture, it's easy to ask a question in the lecture theater or in person, but even on Zoom, if there is an opportunity, just ask the lecturer to stop, pause for a while, send a message or raise your voice to ask. Okay. The other thing that I would say is most of the core units of study, fluid mechanics, soil mechanics, there would be a textbook that would be recommended. A textbook is a very valuable resource. It will have lots of details that an instructor cannot cover in a 2-hour lecture or during a tutorial. So get into the habit of reading the textbook. That's quite important. Also pay attention to what an instructor is saying in class and what are they emphasizing on. So if I'm spending 2 lectures on a particular topic or particular question, then it's important. If I'm saying something repeatedly, okay, and Tim does this, Tim Wilkinson, that he will emphasize something multiple times. If he's saying something 3 times, it's important. If it's saying 4 times, it's going to be probably in exam. Okay, so pay attention to any emphasis that the instructor is giving. Okay, and lastly, take opportunity to do face-to-face or live learning. Okay, you have the luxury of watching recordings later on, but when you watch a recording later on, you don't get the opportunity to ask a question. So if possible, always attend a live lecture. Yeah.
Some very good advice there. Thank you. So you were speaking about fluid mechanics before. Do you have any advice for students who might struggle in CIVL 2611?
Okay, this is tricky because if I give an advice and you don't do well, don't blame me. But
we won't.
Yeah, fluid mechanics, it requires a good understanding of mathematics. And there is, if you don't see much maths in 2611, you definitely will see a lot of maths in 3612. I promise you that. So revise your content of the engineering mathematics courses that you have done. Okay, that will help you a lot, where you will not worry about the mathematics, but you will pay attention to the concepts in fluids. Fluids is a fascinating phenomena. It's something that is quite interesting once you don't have to worry about the maths. There are some interesting physical aspects to fluid mechanics that I hope that you would enjoy. So one of the things to do is pay attention to the interpretation of the equations. So you will be given an equation, rather than worrying about how did they derive, take a derivative or did an integration, think of what it means in a physical sense. For example, if you see a Bernoulli equation, try to relate the Bernoulli equation with something physical that is around you. And you can do that by just looking at a glass of water. Okay? And ask many questions repeatedly. I will keep saying this, ask questions. And most importantly, use the discussion forum. So I know that Chengwang in 2611 has a discussion forum. In 3612, we have discussion forum on EdSTEM. Use that discussion forum where you will get a lot of help.
Yeah, those discussion forums are great. Looking through them is always helpful. So second year is usually when courses start to split into each discipline. Do you have any advice for students who need to take core subjects that might not be in the area that they want to pursue, or might not be in the kind of area that they want to major in after second year?
This is a question which is often asked, and it is dangerous, in my opinion, to discount a unit of study just because it doesn't align with your preference in second year. Okay, if you start thinking about this in the fourth year, maybe it's reasonable. But if you follow the trends of engineering is constantly becoming interdisciplinary, and you might become a structural engineer, but you might have to talk to people who are not structural engineers, who might be fluid mechanicians, or who might be coming from geosciences. And when you go as a professional, let's say you're a structural engineer professional, and you talk to someone who is not a structural engineer, you at least need to know what their background is and have some sense of their technical expertise. Okay, you might not need to be experts in their area, but you should be able to appreciate it. You appreciate what would be the challenges of putting a tall building in a region where the soil is soft. Okay. The other thing is the concepts taught in the second year, they are not categorized. Okay. Some concepts in statics or mechanics can be applied to soil mechanics, geomechanics, fluid mechanics. Okay, some concepts of Lagrangian motion, okay, which are taught in fluid mechanics, can be applied to particle mechanics in geomechanics. Okay, so these concepts are generic in some sense, and they can be easily related to between different disciplines. So you should think of these core units of study as an opportunity to develop a broad fundamental base, okay, which will help you to be an open-minded engineer, even if you specialize in something. The other thing is, do not discount the idea that you might have to change your specialization later on, either due to your preference or by compulsion. Okay, the reality is that many of you will not work in the area that you prefer today. Okay, and you need to have that flexibility. I know many academics who changed course later on in their life after their PhDs. Okay. I did my undergraduate degree in mechanical engineering, and I'm teaching in civil engineering. So I would say these core units are an opportunity for you to actually become a better engineer rather than avoid them or just have a mentality of passing them.
Yeah, I think that's really important. I think we've got a couple of questions actually from our sign up form on how interdisciplinary engineering helps with getting a job in the future. So I'm sure we'll touch on that again later. My next question is, what are the typical time commitments required for 2000 level units?
So for a core unit of study, I would say if you have a certain amount of contact hours, which would be lectures plus labs, okay, and any other contact hours that the unit of study has, you should devote the same number of hours on your own or in a group. So I would say double the contact hours. At a minimum, a rule of thumb is 10 hours per week is required. Okay. Think of doing second year engineering, third year engineering as working full time. And if you're taking 4 units of study, that equates to about 10 hours per unit of study.
Yeah, for sure. That makes sense. And my final question for you, Kapil, which I'm sure lots of people will be interested to hear, is about coding. So I know that lots of second year subjects either start or require a lot of coding. Do you have any recommendations for students who struggle with that?
Okay, this is tricky because we are civil engineers and we still don't have coding as a critical integral component of our units of study. So it comes, it is not a consistent aspect. So sometimes you will do coding for a unit of study and then you will forget about it. And then 3 years later, you might have to do it again. However, most engineering practices require knowledge of coding, okay, where even if you don't do coding, you will have to understand how some algorithms are working, and if you need to change them, what to do. Okay. I don't want to say get over it, but it is something that you won't be able to avoid. So you just need to get along with it. The important aspect about coding is the more you do, the better you get. Practice is important. Okay. If you write an algorithm to add 2 plus 2, and then tomorrow you can do more complex algorithms, and the more you do it, the better you get, and it will become faster. Okay. Today it might take an hour to write 10 lines of code. Tomorrow it will take a few seconds. Okay. There are resources available in the school and in the university. Dr. Benji Marks, he has a winter school on coding. Sydney Information Hub, SIH, has a Hacky Hour, which is quite useful. LinkedIn Learning, which you should have access to, has free courses. And Coursera has free courses. Again, the message is do more of it. The important aspect, one thing that you would also struggle with is sometimes you will get a confusion whether which programming language to use. Should I go with MATLAB? Should I go with Python, or should I go with something else? Okay, I would say the two emerging, or Python is obviously emerging, but MATLAB is something that is quite strong. Both of these languages have substantial web support. So there is, if you start looking up algorithms or just look up help online, you will find a lot of help on both of these programming languages.
Yeah, definitely. It's definitely tricky when you do it in one subject and then have a big break from coding and then start again. But
yeah,
it is that constant practice that I'm sure will make it easier. Thank you so much, Kapil, for answering all those questions. I know you were talking for a long time. I'm going to direct my questions towards Mike now. We're talking about the 1000 level units, and we know there are quite a lot of first years here, so I'm sure that is of great interest. Sorry that you've had to wait around for a while. My first question to you, Mike, is what do you think is the hardest 1000 level unit? And do you have any advice for that unit?
I'd actually agree with Kapil when he said it depends a fair bit on your background. I think especially so in first year, because you're coming, especially in semester one, you're coming straight in from wherever. So I think it does depend on, for example, if you haven't done a lot of physics, statics can be very hard. Depending on what sort of maths you've done, some of the maths units can be hard. And the same with computing. If you haven't done any coding before, computing can be challenging. So yeah, and geology, I mean, a lot of people struggle with geology actually as well. So yeah, it varies a lot. I would say, in terms of what students struggle with the most in terms of failing, is probably computing in first year. And I would also point out, I see quite a lot of students actually who fail PEP the first time they do PEP, or not fail, but don't meet the requirements for PEP. So I'd take the opportunity to remind people to get on top of their PEP. Obviously, if you're here, you're probably already getting on top of it, but I do see a lot of students that don't meet the requirements for PEP at some point, whether it's the first one or some of the other ones. So yeah.
I didn't actually expect many people to fail PEP, but it's definitely an organizational thing, right? Just getting yourself sorted before the end of semester so you don't fail PEP.
Yeah.
My next question to you is, what are the most useful resources that you think more students should utilize that the university offers, or just anywhere?
Yeah, I think generally speaking, I think the best resource for students is tutorials and tutors. I think that time that is allocated to tutorials is really a very good place to learn, and engaging with your tutors, I think is a very valuable resource. I mean, the tutors, they're there to help you. So you should just be, anytime you've got questions, don't be shy, especially if you're first year and you're sort of a bit shy about interacting with the tutors or whatever. Their job is there to help. They're there specifically to help you. And no question is, there's no stupid question. You're just in there with the tutor and just ask away. And it's also an opportunity too, I think, if there's something in the lecture material that you weren't completely understanding, and maybe you didn't get time to ask the lecturer after the lecture or something. There's also an opportunity, the tutors are all up on the material as well, so they're very knowledgeable. So you don't have to only ask them about, tutorial questions. You can also ask them to go through something in the lecture that you didn't understand, and so on. So yeah, just don't be shy, just ask the tutor everything, and any uncertainty you have, make sure, you don't leave the tutorial class in any doubt about anything. I think the most underutilized resource that I know of, I think, is a thing called iWrite. And it's like, like as in IWRITE at sydney.edu.au. It's a website, it's a web resource for writing skills. Even if, you know, English is your first language and you just want some more skills, but it's engineering based, and like it's targeted for engineering students. And it's got a whole wealth of information on writing lab reports and how to approach your thesis writing, and just general writing in reports and writing technical documents and so on. So yeah, it's kind of, over the years, it's kind of faded into the background a bit. And probably a lot of you have never even heard of it, but I think it's a, yeah, that's it in the chat. I think that's a great resource for writing, and I often point students towards that if they, not so much about like English language, like the grammar and all that, but more about just how to construct a technical report and a technical argument, and some great help on when you get to your thesis. There's some great help there on doing literature reviews and arranging a thesis and so on.
Yeah, that actually sounds amazing. I didn't know that that existed. Thank you, Liv, for putting it in the chat if anyone needs to, yeah, go and check that out. So I know that Kapil briefly spoke about this before, but how important is the recommended textbook for courses? Do you think that following the slides and the lectures is enough, or do you think getting the textbook is always essential?
Well, I guess it's hard to define enough. I mean, if all you want to do is pass, probably the content you get given is more than sufficient. I guess it's more about, you know, if you want, I remember when I was an undergrad, I used to find looking in textbooks and stuff, I used to do that mostly just to get extra problem sets and so on. So I felt like I really, you know, because you may, depending on the unit, of course, and the topic, but if you've done the problems that have been provided to you and you still feel like you need to do a bit more calculations and problems to really understand the topic, sometimes that's why I would go and search out textbooks. Of course, if you want to dig deeper into the topic that a unit's covering out of personal interest or out of wanting to understand it better, then the textbook is always a good source for that too. But it does depend on the units a bit too. I mean, something like statics, for example, you could go to the library and like there's literally an entire shelf of statics books, and the same with mechanics. But then that may not be true, you know, for all the units you do. So it depends a little bit on the subject too, I would say. So yeah, I mean, you're going to get everything you need in the unit, but for that extra understanding and extra problem solving, I think a textbook is very useful.
Yeah, I think that's great advice. But sometimes, so you're saying that sometimes you don't have to pay for the extra questions, but it's helpful to have them if you have that ability. My next question, which was also kind of directed at Kapil last time, what would you say is the time commitment required for first year units? And are there any that stand out as requiring more time than others?
My opinion in first year is, I would suggest maybe not necessarily a number of hours, but I think most importantly is to get into good study habits. I think you should be doing some time every week on every unit in your own time. I think that builds good study habits for later on. How many hours you'd need? Well, I guess, you know, in first year especially, it depends on the units and your background knowledge. You know, sometimes you'll be doing some maths, which you actually already did at school or something, so you're kind of on top of it. Or you're doing something, you know, maybe you haven't done much physics and you're doing statics and you feel like you actually really need to do quite a bit of extra work to get on top of it. So I think the number of hours would just suit the situation and the person and the individual. But I think generally speaking, I think ideally everyone would be getting into the good study habit of making sure you sit down and allocate some time to every unit to work on the unit outside of the allocated hours each week.
And do you think there's one subject that requires more time, or is it kind of the more difficult subjects that you discussed before? If you're finding it difficult, you spend more time. Kind of...
Yeah, I'd say it's a bit difficult to generalize in first year. Yeah. Yeah,
of course. Okay, so only one more question for you, Mike. So CIVL 1900, Intro to Civil Engineering, its aim is to introduce students to different civil disciplines. Do you have any advice for students at the beginning of their studies trying to figure out which discipline to pursue?
Well, I would say don't worry about it too much in first year. I mean, you don't really have to worry about it all in first year, to be honest. For a start, in the first 2 years, you're doing core units anyway, so you don't actually have any choice until third year. So there's genuinely no need to make a decision until you're going into third year. And like you probably already noticed, you can just jump on and change your specialization, or in fact, just go to no, you don't have to have a specialization at all either. So I'd say don't worry about it too much in the beginning. And you know, your preferences might change anyway after you do a few core units in an area. So I'd say just let year 1 and year 2 do its work, which is to introduce you to, you know, you'll be doing entire units in all these different disciplines through first and second year. So you can use those units to get a more of a detailed feel about what that specialist area involves and whether you actually have any interest in it. But I'd say about majors or specializations more broadly, I would say they're perhaps less important in the workplace than you might think they are at university. I mean, for me, my opinion is the best approach is to get as much breadth as possible. And the reason I say that is because that gives you the most options as possible later on. You know, if you've done a bit of everything, if someone asks you, have you ever done a bit of this? You can kind of say yes, whatever they say. So that's on the one hand. The more options, in my opinion, the more options are better, especially, you know, I mean, you're going to be going out in the workforce and working for like 50 years. You have no idea where you're going to be in 10 years or 20 years or 50 years. So the better grounding you have in all the different types, I think my opinion is the more options you'll have later on to move around. But I would also say, I don't think it's super important for employers, to be honest, what your major or your specialization is. And certainly a lot of employers aren't going to pigeonhole you like that anyway. I mean, if you're going to work for particularly these larger companies that have all these different specialist areas within the company, they're probably going to move you around anyway to see what they think of you and what you think of them. And, you know, you may end up, regardless of what your specialization is, they may end up just putting you in an entirely different spot anyway and going, well, you know, we need you over here, or, you know, a lot of the graduate programs will let you move around quite a bit to see what you think of the different types of areas and so on as well. So yeah, I'd say probably don't worry about it too much. But of course, if you have a particular interest in something, then why not specialize in it as well? So, you know.
Okay, yeah, so don't put too much focus on pigeonholing yourself into anything in particular yet, particularly in first year. You don't get too much choice anyway.
In first year, yeah, honestly,
yeah.
In first year, don't worry about it.
Yeah. Wonderful. Thank you so much, Mike. That's all the questions I have about 1000 level units, but I'm sure lots of questions will be directed towards you in the Q&A. I'm now going to direct questions on 3000 level units to Hao, and Hao is the third year coordinator. So my first question for you, Hao, is out of all the 3000 level units, which unit do students find the hardest, and what would you recommend students should do to do well in these units?
It's difficult to say which one is hardest. The 3000 level units include some civil stream core units, concrete structure 1, fluid, mechanics, steel structure 1, engineering design. It also includes a number of civil stream electives like structure analysis, geotech engineering, hydrology. So these subjects obviously require a lot of knowledge from second year. For example, steel structure and concrete structure use a lot of structural mechanics. The fluid mechanics introduces more advanced topics than the introductory fluid mechanics. Structural analysis is continuation of structural mechanics. Geotechnical engineering use knowledge of soil mechanics. So if a student did well in year 2, so you will be in a good position to study well these 3,000 level units. If you didn't do very well in year 2, it's time for you to review these fundamental subjects. I had worked in industry for 3 years as a designer before joining senior uni in 2008. From my own industry experience, I can tell you these 3,000 level units are very practical because they are related to the design of civil facilities. They are very relevant and useful if you want to become an engineer or designer after you graduate. So these units will give you an idea what kind of work is to be expected as engineer or designer on a daily basis. It will also help you to decide if you would like to choose engineering as your career path. So my suggestion is that if you want to become a good engineer and designer, then these 3,000 units are very important, and you need to spend time and do your best.
Wonderful, great advice. Thank you, Hao. My next question is, what are the most useful resources that you think more students should utilize? That question has been answered.
I think for this question, Kapil and Mike's answer apply. Is also applicable here. Take advantage of tutorial and ask questions. Not just to the tutor, you can also talk to the professors and the lecturers. Send an email to professors, make appointment, and I don't think any professor will say no. Okay, and also talk to your peers, your friends, your classmates, and help each other. I think these are the resources. And another thing is about the textbook. Now, because many of these 3,000 units are very, the basic civil subjects like steel structures and concrete structures. You can find many classic textbooks on these topics in library. So you don't have to buy those textbooks. Just get a classic textbook as a reference book. It may not be exactly the textbook your lecture specify as class, but in many cases you can find relevant textbooks from library. So just utilize this kind of resource.
Yeah, I think a common theme, obviously, from all three of you has been that utilizing your professors and your tutors is obviously really important, and they're there to help you. And there's a wealth of information from all of you. But very good advice, thank you. My next question is, do you have any tips for students who are looking to achieve higher marks in their 3,000 level units? And how does this compare to the required time commitment to pass? So do you think the students who are looking to get HDs need to be putting in a lot more time than students who are just looking to pass? Or
I think from my experience, I think 30-year subjects are typically easier than second-year units. If you look at failure rates, certainly 3,000 units of failure rate is less than the 30-year subject, and also for the HD distinction rate will be, I think, higher than the second year. It's not just because they are easier. I think if you want to do well in these 3,000 units, first you need a good knowledge about 2,000 units. There's knowledge like structural mechanics, soil mechanics, introductory fluid mechanics. So if you're really aiming for a high distinction, first you want to make sure you get a good knowledge base about 2,000 2,000 units level units, and review those subjects, particularly at the beginning of the semester. But definitely, I think if you just want to pass, if you want to get a HD, the time will be will be different. You spend on these subjects.
Yeah. Do you have any specific tips for students who are looking to get those HDs or even Ds?
You have to go deeper, right? I guess that's general, not just for the 3,000 units. Same thing applied to the other units. Yeah. Because I think it's a lecture, they will introduce some basic fundamental principles, knowledges at class that expect students to understand, right? And that probably will cover maybe 50 to 60% of final exam or assessment. Then 20% additional is more advanced, right? If you want to achieve 75 or 80, that's it. But if you really want to achieve high distinction, that's the remaining 10%. Probably the lecture didn't talk too much about that. It's a class, but the lecture will give you the tools to attack those questions. But it's up to the student to really understand the fundamental, think more, and yeah, I think that's it's difficult to say, but
no, of course,
but as
that's good
students get experienced, yeah, you will know that.
Yeah, I definitely think that advice about it being kind of that extra 10% is what's going to get you the
right.
HD is really important. Got to go a bit deeper, yeah, for sure. My final question for you, Hao, is actually there might be two more. What would you say that there is a significant step up in difficulty from 2,000 level units? I know that you've briefly discussed how you actually think 3,000 level units are different, but what do you think is the difference between 2,000 level units and 3,000 level units?
I think 3,000 units, they are more practical. They apply a lot of knowledge from second year. So if student, well, some students, they're good at maths, they can do good at second year, but they may not as successful as the second year in third year. So that it's a bit tricky, because third year subjects, first you need to be interested in these subjects, right? So if you're not interested in civil engineering, if you're not interested in steel structure or concrete structure, obviously you don't want to spend a lot of time. So the first thing is that students need to be passionate about these civil subjects, and they want to be a good engineer in the future. Then the student will spend time. As I mentioned, these 3,000 subjects will teach a lot of practical stuff, more related to the real engineering design. And so your students will get an idea of what kind of work is to be expected as engineer in the future, if they want to become engineer or not. So it's actually, I think it's good opportunity for students to think about their future career. Some students may lose interest, right? After that, I don't want to design steel structure. And this is not what I want. I may just go to the double degree, becomes choose another path. Yeah.
So as you were just saying, obviously, as you're getting into the 3,000 level units, you're coming towards the second half of the degree. Do you have any suggestions of what kind of skills students should take from their 3,000 level subjects that will help them as they begin to go into graduate work and into their careers of the future?
I think the first 3,000 a year subjects, because many are design subjects. So actually students need to develop skills to solve a real problem. It's not like, in the first year, if you take a math subject, it's more like science. But in the third year, it's more about engineering. For the same question, like design, right? There's many solutions. So you have to apply the principles of like engineering and mechanics to achieve a solution. It might not be the optimum, but as long as it can, achieve the goal, it should be okay. So I think it's for students, it's their ability to solve a real problem. I think that's important. And also some subjects require teamwork, like a design, right? So you have different teams, team members, how to distribute works and how to the deadline, those kind of things, important for future work.
Wonderful, thank you for that. So now I have a question for both Mike and you, Hao. It is, how should students go about learning with the mix of remote and in-person teaching that is occurring right now? And do you think that this mix of learning will now be ingrained in the university system?
Mike, maybe you know better about this.
Yeah, sorry, it is a bit off the cuff.
No, that's right. Do you mean mixed as in like some students at CC and some RE, or you mean mixed
I think
within?
Yeah, that, but also lectures online and tutorials in person, or even just being in a tutorial where some people are in person and some people are online. Kind of the mixed
tutorials are challenging.
Yeah,
especially from a teaching point of view, actually, as well. But I mean, I don't think we're going to have them for long. And well, hopefully, I mean, who knows, right? But and again, with the lectures being online, with the tutorials on campus, again, I would say, especially true now that you really need to use that tutorial time to make sure you're keeping on top of things, because you're a little bit sort of removed, I guess, from the lecturer. I mean, even if it's a live Zoom lecture, it's still, you can't really interact with the lecturer very well. So yeah, it's still challenging, definitely. But I think, I guess it depends how things go. But if things keep, if the whole COVID thing keeps calming down, then I don't think we're going to be doing what we're doing for much longer in terms of all this remote stuff. I think that's going to be, a thing of the past as soon as possible, both from the students' point of view and from the academics and the university's point of view. So yes, it's a challenge, and it has been a challenge. I mean, seriously, like the last 2 years, I mean, it's been extremely challenging. But, hopefully, we're coming out of it now. I really hope so, for everyone's sake, but I guess we'll see how it goes.
Yeah, definitely. Do you have, alongside that, kind of as a second part to that, do you have any tips for students in that transition from going from fully remote learning last semester to, at least for lots of people, pretty much fully in person, as long as for tutorials this semester? Like how can they go about making that change a bit easier on the learning?
Well, I guess it's no different to, coming in as a first year into an on-campus tutorial. It might take you a couple of weeks to get in the swing of it, but, it's just a tutorial class. You'll get used to it. Like, being on campus, like I said, it's an opportunity to really interact. So interact with the tutor, interact with your friends and peers, and, make friends and make groups and discuss the problems amongst yourselves as students, and discuss things with the tutor. And so really, I think, you might be a bit shy in the beginning, having either just come from school or having just spent, a year or two trying to navigate the online situation. But I think for most people, after a few weeks, that shyness will dissipate, and really just, like I said, take the opportunity as much as you can, just to, be around people and like talk to everyone, and, and just doesn't have to be about uni the whole time. You can just, talk about
Yeah, for sure.
life.
Today's
just
only
normal
my
stuff,
first day
so.
on campus, and it's definitely a much more enjoyable learning experience for sure. Just to be able to
Yeah.
actually talk to people and like that part of tutorials
Yeah.
where it gets a bit quiet, you can actually speak to someone instead of just sitting at your desk. It's quite nice.
Yeah, well, I mean, it's interesting actually that you say that, because, you know, the way I run my first year tutorials has always been, yes, we're here to do work, but we're also here just to chat. And my first year tutorials have always been very noisy, and I like that. You know, I don't tell anyone to quieten down or anything. I like that people sit there and chat, and I really don't care if they're not even chatting about the work. I've always liked a very sort of noisy and interactive sort of tutorial atmosphere. And the whole Zoom tutorial thing, I mean, it's basically impossible to do that in a Zoom tutorial. And that's one thing I've really noticed with the whole online thing is, you know, Zoom tutorials are just so, you know, everyone's sort of disparate, and there's really not a lot of interaction going on, and they were really challenging. So yeah, I think just take advantage now that we're back on campus of just being able to like sit next to someone and talk to them and have a chat with the tutor, and you know, make a bit of noise, and you know.
Yeah, definitely. I reckon that was the hardest part of Zoom, just being so by yourself and not having just be able to make side comments to the person next to you.
Yeah,
one
it's
more
tough.
question that I'm sure everyone is eager to know. Do you have any tips for group assignments? Obviously, all of engineering, there are quite a lot of group assignments. Any other degrees if anyone's doing them. Do you have any tips? This is to you as well, Hal, if you've got any.
Yeah, did you want to make a comment, Hal?
Group assignments, I think it's from the beginning of the assignment. I mean, the group member needs to have agreement, right? Like who we're focused on which part. Okay, then just follow this distribution of workload. I think this is also important in the future if you become engineer as designer, because you work as group many times, and you have to. It's still like in the same a bigger project, like a group assignments. So just do your bit and always follow the deadline. I think that's my take.
Yeah, I guess I'd say the same thing, especially with do your bit. You know, just participate. Like no one, you know, it's not good for anyone if there's a team member who's not contributing, or you know, so it's you know, or you know, make an effort to participate. And I'd also say, look, that they can be challenging. In fact, they're frequently challenging. But it's, I mean, that's life, right? You go out in the workplace, you're not just sitting you're almost never sitting in a cubicle by yourself on a computer, right? I mean, sometimes that's the case and it depends on the job, but 90% of the time, you have to interact with other people within your group. You have to interact with people outside your discipline and outside your company, and clients, and I mean, you're interacting with people the whole time. So, you know, better you learn those skills here than have to learn them on the job is what I think. So, you know, just get into it and practice for when you're out in the workforce.
Yeah, I think that's great advice. Thank you. It is one of the more testing parts of the degree sometimes, those group projects, but it's obviously a way better place to be able to work on it at uni than once you get out into the corporate world and have to do it. And the last question is, yeah, so I think we're going to head into the Q&As now. So Arch has been sending out the link for the Slido, and he will be facilitating the Q&A. If anyone who's listening has any good questions to ask, Kapil is just away, but he'll be back in a few minutes. But if you have any questions to ask any of the three academics, please put them on the Slido. And I will pin Arch and he will start asking the questions.
Hey guys, I'm just going to share my screen so you guys can all see the questions while I'm asking them. As always, like I've said in the chat, leave any questions you guys want answered for the lecturers in the chat, and make sure you leave a like on your favorite ones, because that's the ones that are going to be answered first. So these are just questions asked by students. If any of you guys want to answer them, feel free to. We'll start off with the first one. How and what are the challenges or suggestions in the transition from a fourth year student to your own professional career?
Well, I guess one of the things is just being thrown totally in the deep end. Like really, at the beginning, you just know nothing. I mean, you learn a lot of stuff at uni, but you know, there's just so much you don't know, and you go into the workforce and you realize that there's just so much going on that you have no idea how to do. But you know, that's a transition, and a lot of the company, I mean, they do it anyway, but you know, seeking out a mentor, and you know, a lot of them have graduate programs and mentorships. And I mean, most young engineers are going to be working with senior engineers anyway. They're not just going to let you work by yourself. So you're going to be attached to someone either through a seniority relationship or a mentorship or some sort of graduate program. So I think just take full advantage of that. And yeah, I mean, it's a tough transition for sure. It's a very steep learning curve.
Because I worked in industry for several years, so I know a little bit about this thing. Like Mike said, there's a lot of things to learn, particularly when you first start your job as engineer. Because in civil engineering, experience is very valuable. Okay, you can learn a lot of things. You learn how to analyze statically indeterminate structure. You know how to analyze like the buckling mode of a steel column. But the first day you go to industry designing firm, you will find it's not exactly what the problem you have tackled at a school. You may not know how to find exactly the load distribution of the beam applied on the beam. You don't know how to simplify the boundary conditions, those kind of things. But at this point, first you learn, right? You learn from your colleagues, learn from your supervisors, but also, you know, at that time you apply the basic knowledges, fundamental principles, learn from senior uni and apply to solve a real problem. Use a lot of simplification, those kind of things. Yeah. So that's my my bit of suggestion here. But of course, you need a solid fundamental knowledges learned from a uni in order to be a good engineer in your career.
So kind of just get thrown in the deep end, and just kind of these soft skills and stuff that you learn at uni as well, I guess is really important as well.
Right.
We'll move on to the next one. I don't think you guys are like very qualified to answer that one. So I'm pretty sure, yeah, that one's related. How to handle work-study balance in senior years? If you guys have any tips on that.
Yeah, it's an interesting question, this one. This has changed a lot over the years. When I was an undergrad, we virtually never worked in engineering companies while we were still undergrads at uni. A lot of us had jobs, but they were just, you know, they weren't engineering jobs. They were just to get some money to support ourselves. I think one of the things that's changed is just the contact hours and the sort of time engagement with the university. I think that's changed over the years. Like when I was an undergrad, we were doing 40 hours a week contact. the whole time. I think in fourth year I might have had 1 day off a week, but that was like only in fourth year. So I think that's been a thing too. The contact hours has shifted a bit. And I see a lot of students, I mean, it's probably these days, it's like most students are working in engineering companies in their senior years. I do see, as the undergraduate advisor, I do sometimes see students who get themselves into a bit of trouble with failing and so on because they spend too much time doing work. So it is a balance you have to be wary of. I mean, it doesn't happen to a lot of students, but it certainly can happen. So yeah, you certainly need to be very mindful that it does need to be balanced. You can't just sort of, you can't work full time and study full time, mate. That just doesn't, you know, that's just not achievable. Of course, you know, you can work part-time and, you know, a day or two a week or whatever and still do well in uni. So yeah, I would say be very mindful of where you're putting your time. And I mean, my own personal opinion is once you leave uni, you're going to be working your entire life. So my personal opinion is, you know, don't get too far ahead of yourself. You know, you'll only do fourth year once, hopefully. So my advice is, you know, gravitate more towards working less and studying more and getting good marks, and those are your good marks forever. Like that, you know, that's your transcript. It's a permanent record, right? So you're not going to go back and go, oh, well, I only got a credit in that, I'd like to get an HD, I'll go and do it again. Like that's not going to happen. So yeah, be mindful that it is a balancing act, and maybe have a think about that. You know, what are your motivations? You're going to get a job, right? Everyone's going to get a job. So you don't have to worry about, oh, if I tell this company I don't want to work for them in my fourth year, or if I want to reduce my hours and they get upset. Look, you're going to get a job, if not with them, with someone else. You know, there's a lot of work out there and there's a lot of demand for engineers. So I wouldn't let the sort of idea that you're going to miss out on something perturb you. And just have a think about, you know, if you really want to achieve some high marks and achieve a high result at uni, well, you are going to have to put the man hours in to achieve that. So yeah.
That was a great answer. Yeah, I think a lot. Yeah, like you said, a lot of people focus too much these days on working and stuff like that. Often neglect putting time and effort into.
If the work is, if the work is related to engineering, like in a part-time, you work as part-time, working for a part-time engineering firm, even like a drafter, that can be helpful in the future, because you can accumulate experience. Like I said, and this engineering values experience a lot.
Yep. All right, we'll move on to the next question. After coming back from full online learning, what advice would you give students on being able to motivate themselves more in their studies?
How? You got any comment on that?
I think students should be excited coming back to campus. So the students should be motivated already, right? Coming back to campus. But I think all the resource, like recorded lectures and PowerPoint slides will be online. So it's just additional, like coming to campus. So students should feel more comfortable and better equipped to study. So Mike?
And if you guys aren't already excited, I mean, SUCE has heaps of events. We have 28 events this year. So if that's not enough to get you excited, then. Yeah, so we'll move on to the next one. What kind of extracurricular activities are recommended to take for improving my professional skills?
What kind of extracurricular activities? Well, I guess it depends a bit on what you mean by professional skills. I mean, you know, if you're trying to improve sort of engineering skills, I guess you're going to try and, you know, engage with an engineering company. I mean, you remember too, you've got your summer holidays. That's always a good opportunity to try and engage in some sort of program with a company. But I mean, you might also, I mean, you can also learn a lot of professional skills in something that's completely not engineering as well. In skills like, you know, managing projects and creating budgets and, you know, understanding how to complete a project within a budget and how to manage your time in a project and talk to clients and talk to you know, government agencies. And so you can get work or get involved in some, you know, activities that have nothing at all to do with engineering, and still learn some really important skills that will be very valuable to you when you're working in engineering. And in fact, a lot of students say one of the things they feel they're in the deep end a bit when they go into a company is all those practical skills, which you just don't learn at uni. You know, you might learn a lot of technical skills, but there's a lot of basic sort of, I mean, you could even call them sort of administrative or project skills that they're actually very important to do. And if you've never been exposed to them before, that can be challenging too. So I guess, you know, I mean, probably at the end of the day, just getting involved in anything's better than getting involved in nothing, but yeah.
Yeah. So we'll move on to the next question. Will taking the advanced maths units make me a better engineer in the end? If you guys have any answer to that.
Not necessarily a better engineer. As I said before, I'm always for maximizing your options and taking the opportunity at university to maximize your options. So if you're capable and interested in doing advanced maths, that can only be a good thing, right? Later on, you may just decide to sort of take a sideways step or even an entire career change, and maybe those higher math skills are going to end up being super important in doing that. You know, who knows? But to be a better engineer, I mean, we use a lot of maths in engineering, but I'm not sure. I probably wouldn't necessarily say routine engineering involves, you know, the higher level maths typically.
Yeah. So next question we'll get into is how many units are recommended for first years to do in a semester with regard to time management and having an active uni social life?
I think just do the normal 24. I wouldn't overload. I don't recommend overloading, and I don't recommend underloading either unless you have a specific reason, because it's just going to take you longer to get through the program. The 24 credit points is a pretty good. It's actually what I think it's actually about right in terms of the load. And certainly the way the units are constructed, 6 credit points, doing 4 6 credit point units is already a lot of work. So I certainly wouldn't be overloading unless you have a very specific reason. But I think you can still have an active social life at that level too. So I probably wouldn't recommend underloading unless you've got progression issues, or there are some cases where we would recommend that. But just to have a social life, I don't think it's up to the individual obviously, but generally speaking, I don't think there's much need to drop units because you don't have enough time to socialize. But I don't want to prejudge anything.
Yeah, so I'll move on to the next one. in fourth year, we have electives, but how do we decide which unit to take just on the basis of its name? Can we have a preview of how the unit will be later?
If you have a stream or like structure or geotechnical engineering, or you decided you want to be a structural engineer or geotechnical engineer, then you can choose the elective in that stream, obviously. But if you don't have a stream already chosen, or you just wanted to maximize your options after you get out of school, then I would say you can choose electives, say one from each stream, one from structure, one from geotechnical, one from transportation. So that also gives you some idea which area you're most interested in, and you can choose that as your career in the future. I think all the electives, we have plenty of information online available, so you can read the syllabus, units of study, and also I think students can send an email to ask the professors of that subject to get more information if students want. Mike, you have anything to add?
No.
Yeah, I think that's the end of our Q&A. If you guys have any other questions, you can maybe send it on Facebook, and maybe we can do our best to handle your questions. Yeah, I'll hand it over to Livia though.
Yes, thank you so much, Arch, for running that Q&A. It was very insightful, lots of good questions there. So I'm just going to wrap up this seminar now. I'd just like to say thank you so much to our panelists for all your insights and for taking the time out of your day to be a part of this seminar. We really, really appreciate it, more than we can say. And we're so glad to have this connection between SUCE and the student body and the Civil Academic School. It's really helpful. And I know that everyone who's come today has taken a lot away from this seminar. And thank you so much for talking so long. We really appreciate it. We really appreciate it. We know it's a long one, this one. And to all the attendees, make sure that you have become a member of SUCE, which you can do through our website. If you're here, I'm sure you've already done it. It's free. Make sure you do that. And our next PEP event, I know there was a couple of questions about this in the Q&A. Our next PEP event is our first installment of the graduate series with Multiplex, which will be on March 2nd. We're also hosting a speed friending event tomorrow on Gathertown, which will be at 5:30 p.m. So if you're looking to make some new friends, meet some new people, definitely come to that. Both the events for those are on our Facebook. So if you're looking for when the events are, or if you're looking for the sign up links, definitely go to our Facebook. I saw a question that they asking whether they get emailed. They don't usually. Go and like us on Facebook or follow us on Instagram or our website, and you can find them there. Our next event for the academic series, which is the one this one's a part of, will be held on March 22nd. So make sure you're at that too to get the PEP hours for this PEP package. And yeah, thank you all so much for coming and being a part of it. Yeah, we'll see you at the next event. Thank you.
Thanks for inviting
Thanks.
us.
Thank you
My
so
pleasure.
much.
Thank you, Olivia.
No problem. My pleasure. Bye.